Most teams first add Redis to shave milliseconds off database reads. That's the playbook everyone learns. But here's what shifts when large language models enter the picture. A single database query costs fractions of a penny in compute. An LLM call? 1 to 10 cents, plus a 1 to 5 second wait. That's roughly 1,000 times more expensive and 1,000 times slower. When the thing behind your cache changes that dramatically, every decision about keys, expiration, and memory allocation needs rethinking. Think about what happens when 1,000 users ask your app the same question, just worded slightly differently. Each time, your system treats it like a brand new request. It sends it to the model, waits for the response, and pays full price again. That's not just a billing problem. Redis processes commands one at a time in a single thread, so every duplicate prompt also sits in line, blocking real questions behind it. You're paying more and getting slower at the same time. Redis processes commands one at a time in a single thread. That's what makes it fast and predictable. But it also means every cache lookup is literal, character for character. It has no concept of meaning. So when your application gets hit with 1,000 slightly different versions of the same question, Redis dutifully treats each one as brand new. That's not a bug. Redis was designed for exact retrieval, not interpretation. The fix isn't replacing Redis. It's adding a translation layer that converts language into math before the lookup ever happens. Compare this to what teams are used to. A traditional cached database row, a user profile, a price lookup might be 100 bytes. Each semantic cache entry is orders of magnitude larger. On cloud providers, a 100 gigabyte Redis cluster runs $15,000 to $30,000 a month. Some teams report spending more on Redis than on their primary database without realizing how they got there. And the invalidation question has no clean answer. A product price changes, you expire that cache entry. Simple. But ask yourself, when does a cached explanation of microservices become stale? The answer isn't wrong today. It might just be incomplete tomorrow. So teams hoard entries they can't confidently delete, and the memory bill compounds month after month. With a normal database, a write operation fires and your cache knows it's dirty. That trigger doesn't exist for AI responses. Nobody pushes an update when Kubernetes releases a new version or when a security vulnerability gets patched. The cached explanation just sits there, confidently wrong, and your users have no idea. That's what makes this dangerous. Stale database cache returns old data, but stale AI cache returns authoritative-sounding misinformation, and the economics make it worse. If you're caching responses that cost 1 to 10 cents each, you're financially incentivized to keep them as long as possible. So teams stretch cache lifetimes to save money, which quietly increases the window where users get outdated answers. The longer you cache, the more you save, and the more you risk. The right choice depends on where your team already lives. If Redis is already running in your stack, adding vector search means one fewer system to monitor at 3 in the morning. No new vendor, no new billing surprise. But if your prompts carry nuanced meaning, medical queries, legal terminology, a dedicated vector database will outperform Redis on similarity accuracy. That precision costs you operational overhead and a second system to babysit. Now the third column is the one most teams overlook. Normalizing prompts before lookup, lowercasing, stripping filler words, catches a surprising share of duplicates with zero infrastructure change. You're trading ceiling for simplicity. For a team spending $10,000 a month on LLM calls, even that 40% hit rate means $4,000 back in your pocket. Most of those duplicates your app sees aren't clever paraphrases. They're the same question with different capitalization, extra spaces, or words in a slightly different order. A 5-line normalization function catches them for free. No embeddings, no vector math, no extra memory overhead. Teams that skip this step and jump straight to semantic search often spend weeks tuning embedding models before they've even measured their actual duplicate rate. That's engineering in the wrong direction. Measure your miss rate on normalized matching first. The numbers will tell you whether vector search earns its keep, or whether you're overbuilding for a problem that barely exists. Here's what most teams discover. That duplicate rate is usually higher than anyone expects. We've seen estimates that simple normalized matching alone catches 40 to 60% of repeated prompts. At even a penny per call, that adds up to real money by the end of the month. So before you reach for any fancy tooling, just log your prompts for 1 week and look for patterns. You might be surprised how many are nearly identical. Thanks for sticking through the full breakdown with us. Hit like and subscribe so you catch the next decision framework. And the full written guide is waiting in the description with the complete decision matrix and cost formulas ready to copy.